In this video, we will see further problems from exercise 8.2 from vector algebra. Question number 4. A triangle is formed by joining the points 1, 0, 0, 0, 1, 0 and 0, 0, 1. Find the direction cosines of the medians. So you're given a triangle. Let's call this as our triangle A, B and C. So let's call this A as point 1, 0, 0, which is this point here, and this as our point 0, 1, 0, and this as the point 0, 0, 1. Okay, so let's define, let OA be a vector where the point A is 1, 0, 0. So O is the origin. Then the vector OA will be I cap. And for the vector OB will be J cap. Because our points is 0, 1 and 0. So the coefficient of I cap will be 0, K cap will be 0. So it's just left with J cap. And OC would be K cap, where O is the origin. Now let's define D as the midpoint of BC and E as the midpoint of AC and F as the midpoint of AB. So what we're asked to find is the direction cosine of the medians, which is AD, BE and CF. Okay, so let's take the first case where we need to find the direction cosine for AD. Now for AD, the point D is the midpoint of B and C. Therefore, by section theorem, we can say that OD is equal to OB plus OC divided by 2, which is J cap plus K cap divided by 2. So for the vector AD, we can define it as vector OD minus vector OA, which is OD is J cap by 2 plus K cap by 2 minus, or OA is I cap, or we can write this as minus I cap plus half J cap plus half K cap. Now the magnitude of AD will be square root of minus 1 squared plus half squared plus half squared, and that's equal to root of 1 plus 1 by 4 plus 1 by 4, which is equal to root of 6 by 4. And that's equal to square root of 3 by 2, simplifying 6 by 4. Therefore, the direction ratios of the median AD is minus 1, 1 by 2 and 1 by 2, and the direction cosines of the median AD is minus 1 by root of 3 by 2, 1 by 2 over square root of 3 by 2, 1 by 2 square root of 3 by 2. And that's equal to, for the simplifying, we can say that it's minus root 2 divided by root 3, comma 1. So it's root 2 divided by 2 times root 3, and taking the root 2 up and 2 down, same like here, we get root 2 by 2 root 3, which is equal to, if I multiply the numerator and denominator here with root 2, then I will get the numerator as 2 by denominator will be root 2, root 3 will be root 6. Similarly, if I'm going to take away this as root 2 and root 2, then this root 2 and root 2 will get cancelled. So you'll be left with 1 by root 6. 1 by root 6. This is a minus here. And same here, this also will be 1 by root 6. So that's our direction cosine for the first median. Let's go to the second median now. So let's take the vector BE, which is the second median here. So again, to define this, our OE vector will be defined as vector OA plus OC divided by 2, which would be, our vector OA is I cap and OC is K cap divided by 2. Then our vector BE can be defined as vector OE minus the vector OB. So that would be vector OE can be written as I cap by 2 plus K cap by 2 minus OB is minus J cap. So we can rearrange it and say 1 by 2 I cap minus J cap plus 1 by 2 K cap. Therefore, our magnitude of BE will be equal to square root of half squared plus minus 1 squared plus half squared, and that will be equal to square root of 3 by 2, just as the previous case. Therefore, our direction cosines of the median BE is, we take the numerator, we take the coefficient of I cap, which is 1 by 2 over root 3 by 2, and minus 1 by root 3 by 2 and 1 by 2 by root 3 by 2. Applying the same principle as the previous case, we can say this is equal to taking the root 2 to the numerator and 2 to the denominator. You get root 2 by 2 times root 3 minus root 2 by root 3, and this is again root 2 by 2 times root 3. So further simplifying this, by using the same method we used for the previous median, we can say root 2 can write this 2 as root 2 and root 2. So it will be 1 by root 6. Further, if we multiply the denominator and numerator with root 2, then you will get this as root 2 into root 2 will be 2. So this is minus 2 divided by root 2 into root 3 will become root 6. Similarly, the next one also will be 1 by root 6. Now let's find the last median's direction cosines, which is CF. So to find CF, you need to first find OF. So our vector OF is nothing but vector OA plus OB divided by 2. OA vector plus OB vector divided by 2. That would be I cap plus j cap by 2, or I can write this as 1 by 2 I cap plus 1 by 2 j cap. Then our vector CF is equal to vector OF minus vector OC. So which is 1 by 2 I cap plus 1 by 2 j cap minus our OC is k cap. Therefore, the magnitude of CF is equal to square root of 1 by 2 squared plus 1 by 2 squared plus minus 1 squared. This is the same as the previous. So this would be a root of 3 by 2. Then the direction cosines are 1 by 2 over root 3 by 2, 1 by 2 over root 3 by 2 minus 1 over root 3 by 2. So further simplifying this, we can say this is root 2 by 2 root 3, root 2 by 2 root 3 minus root 2 by root 3. Further simplifying this, we will get just as the previous ones. We will get this as 1 by root 6 comma 1 by root 6 comma minus 2 by root 6. So that's the median direction cosines of CF.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.